morning. Viscosity. Now here let us consider one layer of gas. Okay. Now let the velocity of molecules in this layer be u. Okay. Now let us consider another layer which is moving with more velocity or higher velocity u plus du compared to u, AB. Let us consider another layer which is moving with less velocity u minus du. In order to reach equilibrium, either the velocity of upper layer must decrease or the velocity of lower layer must increase. So upper layer tries to decrease the velocity of lower layer and lower layer tries to increase the velocity of upper layer. That is, opposite actions are taking place. Now due to this opposite actions only, tangential forces arises between the layers of gas, and these tangential forces opposes a relative motion between the layers of gas, and this property we call it as viscosity. So now here we are saying velocity difference is taking place. Now in order to bring the equilibrium, we must make all the layers to move with the same velocity. So for that, momentum transfer must take place. Momentum means mass into velocity. Momentum transfer must take place between the layers of gas, and this momentum transfer is arising the property of viscosity. Now coefficient of viscosity. Okay. So the tangential forces is inversely proportional to the area of cross section of layers, directly proportional to the velocity gradient. So du by dy we call it as velocity gradient. So velocity gradient means the change in velocity with respect to the distance. So if we club for unit area 1 meter square, F proportional to du by dy. So F is equal to eta du by dy. This eta we call it as proportionality constant, or we call it as coefficient of viscosity. Eta equal to F by du by dy. Let us keep as equation 1. Right. Now the layers which are in attached to OX will have zero velocity. As we go in upward direction, the velocity increases. Let us consider one layer which is at a distance y from OX. I am considering a layer CD above AB, another layer EF below AB. So now these layers CD as well as EF are at a distance lambda from AB. So the velocity in CD layer becomes u plus lambda du by dy. The velocity in EF layer becomes u minus lambda du by dy. Now let n be the number of molecules present in container. Right. Now out of n molecules, let us consider only n by 6 molecules are colliding with each other as well as walls of container. Right. Only n by 6 we are considering out of n are colliding with each other and walls of container. Right. Now if c bar is the average velocity of molecules, then the average velocity for n by 6 molecules become n c bar by 6, right? N c bar by 6. Now next, if m is the mass of molecules, then the mass becomes mn c bar by 6 for n by 6 molecules, right? Now the velocity of gas molecules in CD layer u plus lambda du by dy. The velocity of gas molecules in EF layer u minus lambda du by dy, right? Now momentum transfer in downward direction. Downwards means CD to EF via AB or along AB. Momentum means mass into velocity. Mass is mn c bar by 6 and velocity is u plus lambda du by dy. Similarly, momentum transfer upwards. Upwards means from EF to CD along AB. So that is equal to mn c bar by 6 u minus lambda du by dy. So net momentum transfer in downward direction, it becomes mn c bar by 6 u plus lambda du by dy minus mn c bar by 6 u minus lambda du by dy. That is equal to mn c bar by 6 u plus lambda du by dy minus u minus minus becomes plus lambda du by dy. U strikes off. So now we will get mn c bar by 6 to lambda du by dy. 2 3s are 6. So 1 by 3 mn c bar lambda du by dy. Now as the gas is in equilibrium position, this can be taken equivalent to the tangential forces. So F becomes 1 by 3 mn c bar lambda du by dy. So coefficient of viscosity F by du by dy, that is equal to 1 by 3 mn c bar lambda du by dy by du by dy. So this becomes 1 by 3 mn c bar lambda. But if you want, you can substitute the value of lambda, the mean free path, which is equal to 1 by root 2 pi sigma square n. So eta becomes mn c bar by 3 1 by root 2 pi sigma square n. So n strikes off. So we will get the viscosity equal to m c bar by 3 root 2 pi sigma square. Poise is the units. So this is the expression for coefficient of viscosity. So the momentum transfer between the layers of gas give rise to the property of viscosity. The momentum transfer is taking place only due to the reason that some layers have higher velocity, some layers have lower velocity. In order to attain equilibrium, all layers must have same velocity. For that, momentum transfer takes place between the layers, and that momentum transfer is giving rise to the tangential force, and that tangential forces opposes the motion of relative motion between the gas layers, and that property we call it as viscosity. And coefficient of viscosity is nothing but the tangential force per unit area per second when a unit velocity gradient is maintained between the any two layers of gas. Thank you.